Guys, today I'm going to show you where the quadratic formula comes from. So you already know the quadratic formula because here it is. You've used this already in Algebra 1, so a couple of years ago. And you know that it's based on standard form where a is the coefficient in front of your x squared, b is your coefficient in front of your x, c is your constant, and we have equals 0 at the end of our equation. We start with the 0 on one side of your equation. But you don't know how those two things connect. Like Mrs. Baker, or I, if I had you for Algebra 1, just told you the quadratic formula and you were just like, okay, and just went with it. But that's not good in math. In math, you should understand where something comes from. So that's what I'm going to show you today, is where it comes from. And I'm going to do this with 3 parts. So I want you to take your notes and make 3 columns. So you probably will have to turn your notebook sideways, I would think, to have big enough columns to write in, unless you're a really small writer. So I have a piece of paper that I've divided into 3 sections here. And on the left, I'm going to do an example with numbers. And then I'm going to tell you what we're doing in words. And then we're going to apply that same idea to the general form here, ax squared plus bx plus c equals 0. And at the end, we're going to end up with this quadratic formula. So we can see how we get from beginning to end. Okay, so I'm going to move that over for now. So that's what we are doing here. So the process we're going to use here is completing the square. So when I first look at this equation, I notice that I have an a value that's not just 1. And I don't want it to stay like that. I don't want to have that 3 in front of my x squared. So if I want that to go away, my x squared is multiplied by 3, so what can I do to get rid of that? Yeah, I could divide by 3. So I'm going to divide by 3. Now I have to be fair. Everything in this equation is going to need divided by 3. Okay, so I'm going to divide everything by 3. So step 1, we're going to divide everything by the 3 is in the spot of the a because it's our coefficient in front of our x squared. So I'm going to say divide everything by a. Okay, so these will cancel. So I'll have x squared plus 5/3 x minus 4/3 equals 0. And now we're going to take that idea and we're going to apply it over here to the generic form of ax squared plus bx plus c equals 0. So I don't like this coefficient of a, so I'm going to divide everything by a here. Oh, I should have shown the dividing by 3 here. I just didn't show it because 0 divided by 3 still gives you 0. But I should show it so that you know. Here my a's are going to cancel, so I'll have x squared plus b over a x plus c over a equals, now on the right side, 0 divided by anything is still 0. So I'm just going to write that as a 0. So at least now my x squared has a coefficient of 1. Okay, so that's good news. Now I know by looking, you probably don't know by looking, but this is not a perfect square trinomial. So I don't like this number being in this spot, this number here. So I want to move that out of the way. So how can I get rid of a minus 4/3? What can I do? Well, I could add 4/3. So I'm going to add 4/3 on both sides. On both sides of my equation. So here's the 2 sides of your equal sign. So I'm being fair there on both sides. So those go away. And I have x squared plus 5/3 x. I'm going to leave a blank here, okay? So I'm not gonna fill that in. 0 plus 4/3 is 4/3. So what I'm doing in that step is I'll say move the constant term to the right side of the equals. Okay, so we move the constant term over there to the right side. So that means I need to do this over here with my variables, with my general form. So this plus c over a, to get rid of that, we'll need to subtract the fraction c over a. And I've got to be fair on both sides. So there's the fairness on both sides of my equation. So those cancel out. So I'll have x squared plus b over a is the fraction in front of my x. I'm going to leave that gap. And then 0 minus c over a would be negative c over a. Okay, so I'm going to put a box here so you can see that's the space that I need to fill in to complete this square. Okay, so now I want to remind you about...
Shiloh Thompson, please come to the office. Shiloh Thompson.
I want to remind you about completing the square. Okay, so if I have an x squared, and I want to make this a square, not any old rectangle, I need to have matching lengths and widths. So that means I need the same amount of x's to be in these two boxes here. So in this problem, I have 5/3 x's. So 5/3 x's is how many I have to fill these two spots. I want to split it evenly because I want the length and the width on this thing to match. So that means I need to put half of them up here and half of them over on the side. So I'm going to take half of this. Half of it, half of means multiply. So if I take half of that, I'm going to have 5/6 x. So I would have 5/6 x up here and 5/6 x here. So my binomials on the side have to have x's because length times width, x times x gives you x squared. This would have to be a 5/6 plus 5/6 because think about length times width for that zone. Length times width, that's how you would get those 5/6 x. And when you put those together, you would have 10/6 x, which would reduce to the 5/3 that we had over here. So now is the step in which we get the name. So we need to complete the square. We need to finish out that square there. So think about length times width. So 5/6 times 5/6. So let me do this off to the side here. 5/6 times 5/6 would be 25/36. Okay, so that's what will complete the square. So let's get this in steps here. So to fill in the blank, take your x's, divide by 2, and square that. That's called completing the square. So I had 25/36. Now, wouldn't that change the equation if I suddenly added 25/36 that were not there before? How do I maintain balance? Well, I got to do that on both sides. So in purple, I'm going to add a 25/36 on both sides of the equation because that keeps things balanced. So I'm going to say add this to both sides. So now we're going to do this in the hypothetical situation with all variables over here. So I have my x squared. What I have is b over a, x. So if I still want to split those in the two zones, I still want to take half of them and put it in each section. So that would be b over 2a if I multiply straight across on those fractions. So b over 2a. So we have an x here and an x here. B over 2a, x, b over 2a, x. Hey, b over 2a, doesn't that sound familiar? Didn't that have something to do with, I don't know, maybe the vertex? We'll talk about the negative in a little bit. So let's see, this binomial would be b over 2a, x plus b over 2a. So if you check length times width, that gives you your two sections there. So I took what was in front of my x, took half of it to split it up. Now I need to square that because length times width, it's the same number on the length as it is on the width. So b over 2a is going to get multiplied by b over 2a. So that's called squaring when you do that. So in my numerators, I'm going to get a b squared. My denominator, that would be 4a squared. So that's what will complete this square. So I'm going to add that b squared over 4a squared. I need to balance it and add it on the left and the right of the equation. Okay, so I'm being fair on both sides of the equation, just like I was over here with the 25/36 that I added on both sides. So now, I think I'm going to clean up the right-hand side of each equation first. So simplify the right sides. So over here, to get a common denominator, I would need to multiply by 12, top and bottom on that fraction, so I would have 36ths on both of my denominators. So 48/36 plus 25/36, let's see. So 48 plus 25 would be at 3, carry a 1, 73. So we'll have 73/36. So let me do that over here on the right side here. So I want them to have the same denominator. The green one just has an a, but the purple one has a 4 and an a squared, which is a times a. So I'm going to multiply by a 4a on top and bottom. So if I do that, see how your denominator here will be a 4a squared, because 4 times a, that's 4a squared. We need it to match this one, so that's why I'm doing that. And then I need to be fair top and bottom. Okay, so that will be, it'll be a negative 4ac plus a b squared as my numerator. Let me do that off to the side for a second. So I have negative 4ac over 4a squared plus b squared over 4a squared. So matching denominators, that's good news. You have to have like term or common denominators in order to add those fractions. So I have a denominator of 4a squared. So now my numerator, I could write it two ways. I could write it as negative 4ac plus b squared, or by the commutative property, I could take those two terms and flip them around. I could say b squared minus 4ac all over 4a squared. They're both correct. I'm going to go with this one because we like to lead off with positives if possible. So it's just kind of the more common way of writing it. So I'm going to put that. So b squared minus 4ac all over 4a squared. Okay, so I've simplified the right sides. On the left, I'm going to factor the left sides. Now remember, what we did here was we completed the square. So I know this is a perfect square because in my picture, I set it up that way. If you remember these pictures, you know how the length and the width match on that. That's why it's a square, not a rectangle, not any old rectangle. So I'm going to call this x plus 5/6. It's getting squared because that's the length and the width. And then on this side, with the letters, I'm going to call it x plus b over 2a. Let me show you the picture here. Let's see, where's that? Here it is. Here's the length, x plus b over 2a, and here's the width, x plus b over 2a. So I can say it's x plus b over 2a quantity squared because I'm using that on the length and the width. So there's that. So now I want to get this x here by itself. So this x is added to 5/6, and then it's squared. So I want to get rid of the squaring. Well, how do you unsquare something? The opposite of squaring is square rooting. So that's what we're going to do, is we are going to square root both sides. Square root both sides. And I'm going to say, don't forget the plus minus sign. Don't forget the plus minus, because that's a common thing that people will forget. So I'm going to square root, and don't forget the plus minus sign. On the left side, the square rooting and the squaring make each other go away, so you have an x plus 5/6. And then on the right side, we have plus or minus. The 73 doesn't square root real nice, so I'm going to leave it inside the radical. But I can square root 36. That denominator is going to come out real nice. So the square root of 36 is just a plain 6. So that's looking a little bit better over there. So let me apply that same concept over here on our right-hand column. So I'm going to square root, don't forget the plus minus sign. So I have my little plus minus sign right here if you can see it. The square rooting makes the squaring go away, so you have x plus b over 2a equals plus or minus. Now the top part is kind of complicated. It has b squared minus 4ac in it. But the denominator is square rootable. Just like the 36 over here, I could square root the 36. Well, what's the square root of 4? Well, that's 2. And what's the square root of a squared? Well, that would be just a. Okay, so those are looking better. Now, I almost have this x by itself. This x is added to a 5/6. So I want to get rid of that. So I'm going to subtract 5/6 on both sides. Now, we talked before about if you put this on the back end, it might be questionable how long the square root sign is. I don't know, is it under that, is it not? So I'm going to put the minus 5/6 in front. Okay, so I know I'm kind of squeezing it in there, but I'm putting this minus 5/6 in front of my plus or minus the square root of 73, so I don't get mixed up if that 5 is part of the radical or not. So the step is subtract on both sides. So I got to do that over here. So I'm going to get rid of the plus b over 2a by subtracting b over 2a. Hey, negative b over 2a. That's where it comes from. So I'm going to squeeze it on the front end here. So those cancel. Those cancel. Let's see where we're at. We have x equals, and over here we have x equals. Now, to simplify this, this is good news. I already have common denominators with the 6. So I'm going to write it over 6. So my numerator will be that negative 5 plus or minus the square root of 73. And, oh wait, so this step is I simplify. Over on the right column here, I already have a common denominator. So it's 2a, so I'm going to put it all over 2a. And so my numerator is going to have the negative b from right here, and then it's going to have plus or minus the square root of b squared minus 4ac all over 2a. And I said that you would see the negative b over 2a part of the vertex. Look, if I cover this up, do you see it? Negative b over 2a. That's where it comes from. So, there's my little post-it note. Ta-da! We got there, didn't we? This matches. So that's where the quadratic formula comes from. It's derived, that word means gotten from or taken from. So it's taken from doing all kinds of math of completing the square, that process, and being fair on both sides, and we end up with this formula here. So tomorrow you'll talk about how we use that formula. The getting there is the bad part. Like, this is the bad part. Using it is very handy, and we like it very much, and we're very glad that it exists. So, okay, I think that is everything. So remember that Jesus loves you, and so do I, so do your math.